Okay, so today we're going to go over piecewise functions. We're going to start off with just evaluating a function in piecewise form. So we have this example. A telephone company offers the following plan: $20 per month by 60 minutes. Additional time costs 40 cents per minute. We can represent this plan mathematically by writing the total monthly cost C as a function of the number of calling minutes T. So notice we have part 1, which says we have the 20 minutes flat rate from 0 to 60 minutes. And then anything additional, we still have to pay that $20, but then we're also going to have to pay 40 cents for any minute after 60, which is why this T minus 60 is here. Okay, so a function that's defined by 2 or more equations over a specified domain is called a piecewise function. So using that function that describes this telephone plan, interpret each of the following. So finding C of 30. Okay, well, when we find C of 30, this is going to be the domain of, let's see, how do I want to represent this? Right here, right? So 30 falls between 0 and 60. So if we plug this in, we just get 20. There's no variable to plug into, it's just 20, which should make sense in terms of the situation, okay? If you only talk on the phone for 30 minutes, that's less than the 60 minutes, which means you're just paying $20. Okay, so looking at C of 100, so now 100 is greater than 60, so we're going to be plugging into the bottom equation. So we're going to have 20 plus 0.40 times 100 minus 60. So we have 20 plus 0.4. 100 minus 60 is 40. So we have 20 plus, so 4/10 of 40 is 16. And 20 plus 16 is $36. Okay, now we're going to look at graphing piecewise functions. So there's lots of different ways you can do this. We are going to do a table method, just so it's a little bit more concrete. So we're going to break this up into 2 parts. So we have f of x equals x plus 2 if x is less than or equal to 1, and 4 if x is greater than 1. So our first equation, f of x equals x plus 2 if x is less than or equal to 1. Okay, so I'm going to make a table. And here's the thing, we're always going to use that number, no matter what, whether it's a less than, a greater than, less than or equal to anything. Okay, so starting with 1, and then we want to pick at least one number that makes this true. So if x is less than or equal to 1, so another number that's less than 1 would be 0. And then I'm also going to pick a third number, let's do -1. And now we're just plugging in. So we have 1 plus 2, which equals 3. 0 plus 2 is 2. And -1 plus 2 is 1. So our ordered pairs would be 1, 3, 0, 2, -1, 1. Okay. But before we graph this, we need to figure out, are we going to have an open or a closed dot at our starting point? So our starting point is this x equals 1. Okay. Since it's less than or equal to, the equal to means we're going to have a closed dot. Okay. So I'm going to go on this graph, and we have at 1, 3, a closed dot. And then we have 0, 2, and -1, 1. And it's going to keep going to the left because of our domain. Okay. Now we're going to look at the second part of our piecewise function. And now we have f of x equals 4 if x is greater than 1. Okay, so remember when we make our table, we always have to include that starting value. So 1. And then pick 2 or 3 numbers, or sorry, 1 or 2 numbers that make it a true statement. So x is greater than 1. That would be 2, 3, and continue going up. So if we plug into our function, we're always getting out 4 because there is no variable to plug in. So when x equals 1, f of x equals 4. When x equals 2, f of x equals 4. And for 3, we also get 4. And then before we graph, we need to check, is it an open or a closed circle? Since it's greater than, there is no equality. It's not included in our graph, so it's going to be open. So if we go to 1, 4, we're going to do an open circle. Then we have our point at 2, 4, and 3, 4. And there's our graph. All right, looking at B. Now we have 3 parts. So looking at the first one, we have g of x equals 0 if x is less than -4. Okay, we always start off with that -4, and then we're going to pick numbers that make it true. So a number that's less than -4, that would be -5 and -6. No matter what we plug in, we're going to get 0. Our ordered pairs are going to be -4, 0, -5, 0, -6, 0. And then our first ordered pair, since it's less than, it's going to have an open dot. So I'm going to go over on our graph. At -4, 0, we have an open circle. And then our graph is going to continue going to the left as a horizontal line. All right, now let's look at part 2 of our graph. So now we have g of x equals -x if -4 is less than or equal to x, which is less than 0. Okay, since we have a compound inequality, we want to always include both of these numbers. Okay, so we're going to include -4 and 0. And let's pick a number in between them. Let's do -2. Okay, you could have picked -1, you could pick -3, you could pick -1.5. It doesn't matter. So now if we want to find g of x, evaluating the function, so if we plug in, we have -4, which gives us a +4. -2 is a +2. And -0 is 0. We wanted to write our ordered pairs. We have -4, 4, -2, 2, and 0, 0. And now we need to figure out open or closed. So when x is less than or equal to, okay, here that means we're going to have a closed dot. But then if we look at the other end, we have less than, which means we're going to have an open dot. So we graph this. At -4, 4, we have a closed dot. -2, 2, we just have a point. And then at 0, 0, we're going to have an open dot. And then connect your graph. All right, and last part. Let's slide this down a little bit. We have g of x equals x squared if x is greater than or equal to 0. So make your table. Remember, we always start with our given domain, so we're going to use 0. And then anything greater than 0, let's do 1 and 2. So we have 0 squared is 0, giving us the ordered pair 0, 0. The ordered, let's see, 1 squared is 1. So we have 1, 1. And then 2 squared is 4. So we have the ordered pair 2, 4. Okay, here's a reason why we always want to use 3 points. If we graph this with 0, 0, and 1, 1, that looks like it should be a straight line. But since it's actually a squared function, we know that that's a parabola. Oh, sorry, I forgot to do this part. At 0, 0, we're going to have a closed dot. And since we already had a dot at 0, 0, we're still going to fill it in because for this function, it is a point. Okay. And then we have 2, 4. Okay. Our graph is going to continue to go up because there is no endpoint for that third portion.